Okay, so in this module I want to talk about symbol creation, and I'm going to do this from scratch, taking two components that I want to create symbols for, and those symbols or those components are two sensors. They are LEM sensors that are this current transducer or current sensor, and this device which is a voltage sensor. So I want to go basically from scratch and develop the symbols for both of these in gschem. So the document that I'm going to be following is going to be this gEDA-gschem symbol creation document, and this is available on the gEDA project wiki, and I'm going to be basically trying to follow this step by step, and in case there's anything that is in case there are any discrepancies between this and what we need to do, or if there are any issues, then I will point those out as well. So this may be a little slow, but bear with me. So the first thing to do is to open up a terminal, and since last time I talked about having a GAF folder in your home directory where we are going to keep all our gEDA and associated files. So if you look inside, we are going to have a directory for footprints, one for projects that we are going to develop, and one for symbols. So now I'm going to cd into this projects directory, and this is the first project. So I'm going to say create new directory, make directory, and I'm going to say new symbols tutorial. There we go. So that's a new directory that I've created, and whatever I do, I'm going to put in this for the time being. Of course, once the symbols are created and once we have tested them and we made sure everything works, then we need to copy them into this shared symbols directory, but that we'll do after we have finished creating the symbol and we verified it and maybe had it vetted by somebody else as well. Okay, so that's the general flow that we are going to have. So the first thing to do is I'm going to put this to one side, and we can start following these steps one by one. So the first step here is preparation. So first of all, is the symbol for aesthetic purposes? So no. In our case, the symbol represents a physical component, and the physical component is of course going to have a circuit symbol. It's going to have a footprint and so on and so forth, but we won't worry about the footprint right now. We are only concerned with the schematic symbol. The second is, do I want to simulate this component in question, for example with ngSpice. So again, for now I don't need to simulate this component, but later on I may want to. So for now at least I don't need to simulate, and I don't care about the ability to simulate it. The last one, do I want to use this in a schematic that includes power distribution? So what this means is, we'll come to this later, but essentially it means, do we want to define some pins as power pins or ground pins or something like that? And the reason, even though of course every PCB has some kind of a power distribution system, in our particular case that's not going to apply, and that's because this symbol or this component is going to be used in a system where there's going to be a high voltage side, which means the voltage that we are going to measure, and there's going to be a low voltage or a signal side, which means the measured or the converted voltage that is going to be processed, or it's going to be read, or it's going to be used by the control system, right? So that situation is complex enough without having to define what your power nets are, what your ground nets are. Again, there's going to be a high side ground, which is your power ground. There's going to be a signal ground for the microcontroller or whoever is going to read the output of our sensor. So things are complicated as it is. So we are not going to worry about power distribution at this point. We are just going to define the pins as inputs, outputs, or whatever else we want to do. And for the moment, we are going to ignore this power distribution facility that we have. The last one is, does this symbol represent a component that comes several in a package? So if you buy an op amp, for instance, you're able to buy dual op amps, quad op amps, or if you're buying gates, you're able to buy let's say a hex inverter, right? So one chip in a 14 pin package is going to have 6 inverters and 2 power pins. So that's what it means when you say several devices or several components in one package, and most often they're all identical components in one package. And the way to handle that is called slotting. So you have one component and has multiple slots, and we define or we describe which slot we are going to use. So in our case, one sensor comes in one package, so we don't have to worry about this slotting at all. So we can ignore this as well. The next one, so now we can start building our symbol. All we have to do is start gschem, and note that here I'm starting gschem from my project folder. And in general, it's a good idea to do this, because when you start gschem from the launcher, so when you do this, it starts up gschem sort of in your home directory. So if you want certain project specific configuration, so if you had a GAFRC or gschem-rc sitting in this folder, then those would not get loaded when you started up gschem from the application launcher like this. So what we want to do is we want to start gschem from the terminal, and not only from the terminal, but we want to make sure that we are in the right folder, we are in the right directory, so that any configurations, that we are consciously loading it from this directory, so that we make sure any configuration that is on a per project or per user basis is getting loaded correctly. And of course, in this case, we have just created this folder. So if I do ls, this folder is empty. But just as a matter of habit, it's a good practice to start gschem from the terminal and in the correct folder. So let's start up gschem. So now we have an issue here, which is this invalid path user local share pass to component library. So we'll worry about this later. For now, let's ignore that error. It doesn't seem to be causing any major thing to break. So now that we have gschem open, let me just pull up our tutorial and we'll go to the next step. So now we've opened gschem. Now we've got the empty page. Now this empty page has this title block or this graphical rectangle here, which just helps us frame our components and makes it look nice when we are printing it. So when we actually make a schematic, we could go in, put the title of the schematic, the name of the creator, what is the file name or design name, who has revised it, and so on and so forth. But for a symbol, of course, we don't want this title page to be there. So what we need to do is go and delete locked object. It was a locked object, so we say yes. So now we have basically a blank canvas to work with. So now we can zoom in wherever, because it doesn't matter. And now we start adding things to our symbol. So the first thing to do whenever you are designing the symbol for any component is to actually first look at the data sheet. So let's start with the voltage sensor. So let's start with the voltage transducer LV25P. And whenever you're designing a symbol or footprint for any component, it's very, very important to look at the data sheet first in terms of how the pins are laid out, what pins are there, how they need to be connected, and so on and so forth. So in this case, let's scroll down to the pin description or the pin definitions, which are actually all the way over here. There we are. So now we have these are the pin descriptions, and so there are 5 pins. One is the plus HV, minus HV. These are the high voltage side, which means the voltage that we are sensing. Those are going to be connected here, and then we have 3 terminals here that basically are the low voltage side. So there's a positive and negative supply pins, and then M is the measurement output. So let's see if these names are defined somewhere. So if I go down here, let's see if I can find. Usually there's like a graph that shows you voltage at the input, voltage at the output, and things like that. There's a pin definition somewhere, but that doesn't seem to be here. Of course, it's fairly self-explanatory. Ah, there we are. So this is our equivalent circuit. So if I wanted to simulate this, or if I wanted to do some modeling for this, then I would use this circuit diagram to emulate what's going on between these terminals and what's going on this side. So now we have, let's see. So now we have the equivalent symbol, and this is sort of what we want to capture in our gschem. So now how many pins do we have? We have 1, 2 on the high side, and then we have 3 pins on the low side. And of course, these are actually the pins. So this point here, this point here, this point here, and these two, even though they're not marked in circles, those are the pins that we have to worry about. And this is slightly misleading, I would say, because HV plus HV and minus HV are actually the pins, but it appears here that they are connected. HV plus and HV minus should actually be these points, and these nodes here are actually connected to the HV source that we want to measure. So this R1 that you see externally, this is an external component that we need to add in our circuit, right? So HV should technically or strictly speaking be marked here. So this is what we need to capture in our schematic. So let's go and let's try and do that. So now let's put this to one side, and let's get gEDA. There we go. So we need to capture this. So easiest is, first of all, we go back to our the tutorial, which says first of all we need to open gschem. We've got this, zoom in, that's fine. We've got the zoom set, and then second thing we do is make sure that our snap to grid is turned on. So option toggle snap. So options, and snap is on, right? So snap is on. Then let's see, make sure the snap grid size is set to 100. So let's go and set that. So options, grid spacing is 100. There we go. Right. So snap grid spacing. O shift S. Let's see what O. I believe, yeah, there we go. That's our grid spacing that was getting altered. So we have snap mode is on grid mode is mesh, that's fine. So the next thing we need to do is, now we need to start creating this device, or creating the artwork, right? Drawing the symbol. So now we can use a box in the add menu. So I go here, add rectangle. So I need to add a box like so. Okay, let me restart that. Need to add a box, and let me make it a nice square. See, add box. There we go. And I click to release. So the fact that it's green, this tells me that this is a totally graphical object. There are no electrical parameters or no electrical connections to this. So once we have that, now we need to check what color you are using to draw. We can go to edit color. So now let's try doing that. So edit. We don't seem to have an edit color. There we go. So now EO, these are basically our color options. So we are drawing graphics. That's fine. So now the next thing, once we are done with this, is we need to add pins. So we are going to say add pin, and there we go. So generally, as a rule of thumb, you should keep your pins at least 3 or 4 boxes long. No, sorry about that. So that's pin created. Now I'm going to move this. Now what happens is that this is actually the place where things are going to connect. So let's say I go to the connection tool, so add net. This is the location where electrical connections are made, right? So not this end. So if I go here and I try to join something here, it's actually not joining up correctly. So the electrical end of this is actually this red box here, and so I should orient my pin like this. So that's my first pin. I can do copy, edit, copy, and then edit, paste, and that gives me my second pin. Of course, I'm going to number and rename and do all the things later. Let me just put all the pins that I need down. And so for the next one, I can just do Control-C, Control-V, and middle clicking allows me to rotate them. So middle click, rotate, middle click, rotate, middle click, rotate, and so on. So now this gives me, there we go. So this is my third pin, another paste. Now you can see that this is not in the correct direction, so I can middle click, sorry, I can rotate this using the ER command. So select and then ER, and then middle click and drag to move the schematic. So there, middle click to rotate, and paste. There we go. So now I have all my pins put down on the schematic. Next thing we need to do is look at what are the attributes that we need to add for each of the pins. So let's double click this. So the attributes that are already there are this pin number, pin sequence, pin type, and pin label. So some of these are mandatory, some are not. So let's go and see which ones are mandatory and which are not. So now we've added all the pins. A 0 and the word unknown should pop up. That's all fine. Yes, so now we edit. So now, and EE, or right click and hit edit. So select, edit. There we go. So basically it shows up all of this. If I didn't have that open, EE would just bring up this attributes list. So what are the things we need to add? First thing is all pins should have a pin sequence attribute. So I need to add pin sequence for this, pin sequence for this, and so on and so forth. So what I'm going to do is just go ahead and add pin sequence for all of these first. So that's 1, 2, and so on. So this is going to get painful if I had a larger number of pins. So what I can do is select all the pins, and I can use the auto number functionality. So tools, auto number, and I need to search for pin SEQ. Oh, sorry. Pin SEQ equals star, could be whatever. So the star just means refers to any value. Auto number text in the selected among the selected objects in the current page, and we need to overwrite if they have anything, because they already have 0, so we need to overwrite them. And we've already assigned pin sequence 1 and 2, so we need to start from the number 3 and we'll go top to bottom, and then we say apply. Hopefully this should have worked. So there we go. So pin sequence 3, pin sequence 4, pin sequence 5. So that's done. So now pin sequence attribute, pin sec attribute has been applied, and we start with 1, we incremented on every new pin, and we are done. So now the next thing we need to do is to have pin number attribute. So depending on, this is another sort of point of contention, is whether you want pin numbers to be numerical, like 1, 2, 3, 4, which would be common on, let's say, a dip package or something like that. Whereas some pins can also be defined in terms of letters. For instance, if you have a let's say a discrete transistor, then you might want EBC or BCE or something like that. So base collector emitter. If you have a MOSFET, you may want GDS and so on and so forth. So there's a lot of debate about which you should pick, but in this case we are going to go with fairly straightforward numerical pin numbers. So we are going to number pin numbers starting from 1 all the way across. So HV1, this is going to be our HV pin, so we are going to give this pin number 1. This is going to be pin number 2. This is going to be pin number 3. This is going to be pin number 4, and this is going to be pin number 5. There we go. So now our pin numbers are all assigned. So now first thing to do is, let's just save this file before we lose any changes. So we can say save, and note that here it's saving it as a schematic, but that's okay. So we don't want to lose data, so let's just save it. So this is LV, let's just get the correct part number. So this is LV25P. So LV25P.sch. So now we've got the box drawn, we've got all the pins drawn, and we have got the pin number and pin sequence all assigned correctly. So the next thing we need to do is to give pin label. So this is going to be the name or the label of the pin, not the number. So in this case, it's fairly straightforward. The manufacturer has defined what these need to be. So HV plus is going to be the first one. So HV plus, HV minus. In fact, let's follow this notation. So it's plus HV minus HV, and then plus minus and M, right? So what I would do here is that there are two things that I would like to change. First of all, I don't want to start the pin label with a symbol. So instead of plus HV and minus HV, I'm going to say HV plus and HV minus. And as for these pins, again, I don't want to call them minus and plus, just a matter of preference. But what I'm going to do is I'm going to call it V plus, V minus, and M can stay M. So let's go and assign pin labels for all of them. So we go here and then pin label. So pin label for this is going to be HV plus. Pin label here is going to be HV minus. Forgot to save it. So HV minus and enter. This one is going to be D plus, just to indicate that it's the supply voltage. And then so now we need to be a little bit careful. Let's say that we call this pin label. So what we need to do is we need to just be a little bit cognizant in terms of how we are assigning the pin labels. Okay, so now when we look at this, is this looking at this from the top, you're going to have plus HV minus HV on, let's say, on our sensor, right? So plus HV minus HV, and then on the right side we are going to have negative, positive, and then M. So what I'm going to do is call this V minus, and then this is going to become V plus, and this is going to become M. So if you double click this, you'll see pin label for all of these are now assigned correctly. So that's it for the pin label. So let's get back here. Next thing we need to do is pin type. So this describes the kind of pin. So now the question is, what is pin type? So the pin type values are all of these. Let's see the master attribute document, which of course you can click here, or you can, I have this opened already. So let's go and search for pin type, which is right here. Each pin must have a pin type attribute and should be made hidden. This is not really used much outside gschem, but it will be used for DRC. Okay, so these are the options. So for us, we are going to have two of them being power, of course, and then one of them is going to be output, right? So let's go and set those. So these, since we really don't have defined types, because in case those are especially useful in case you are having digital designs, we don't really have that. So what we're going to do is we're going to say add attribute pin type not visible, we want it hidden, and value is going to be PS, that is this one, passive. And we are going to use passive because no other type really matches what we are trying to do here. So we are just going to go with the default and attach to all of these and replace the existing attributes, because we want whatever was that unknown value to get replaced. So there we go. So now if I check pin type is passive, pin type is passive, pin type is passive, pin type is passive, pin type is passive. So we are done. So now again save, and instead of course I can do Control S or file save. And just a good point always is to keep making sure that things are indeed getting saved, which is just as a sanity check. And now we go on to the next step, which is to add attributes for the symbol. So we finished all this. Pin type is done. Pin sequence and pin number we did, and we also saw how to do it using this auto number functionality. So the next thing to do is to add attributes. So the first thing we need to do is add a device equal to device name. So what should device name be? So let's go and see what the master attribute document defines it. So perhaps it will be up top. There we go. So device is the name of the symbol. It should be placed somewhere in the symbol and made invisible. Then the example is, of course, like if you have a 7400 IC, then device is this. So in our case, this is fairly straightforward. All we have to do is go here and place new attribute, and the way to do that is to add, and then we say add attribute, and then the attribute is device, and helpfully gives us a suggestion LV25T. That's our device. So of course we could be a little more pedantic and put the hyphen here for just to be quite accurate. Doesn't really matter. This is used only for our internal use anyway. So, and we don't want it to be visible, so we've added the attribute. So now, by the way, in case you added stuff and you wanted to see where things got added, we can enable showing of all invisible items. So for instance, this attribute that we added and we marked it not visible, we can see that it's up here, and we can change this to show whether just the name or show the full thing. So that's how you see things, how you see attributes or other parameters that are set to invisible by default. So then we can shut this off again. The next thing to be done according to this tutorial, after this device name, graphical equal to 1 if our device is graphical. It is not, so no problem. Description text, so that's the next thing we need to add. So again, we go back here, and then for convenience, I'm going to keep my invisible text on for the time being, and I'm going to add attribute again. So add attribute, and the way to do that is using the shortcut key. I just double tap A. So there we go. So now description, and so this is a LEM Hall effect isolated voltage sensor. And again, I don't want this to be visible. Let's see what the manual says about this. Yeah, it doesn't require it to be visible, so we're going to keep it not visible. There we go. So that's our description text added. The last thing we need to do is footprint. We don't really need the footprint right now, but let me just add it anyway. So add attribute footprint, and I'm going to say lb25-p. We haven't created this footprint, we don't have this footprint yet, but just for the sake of completeness, I'm going to add this, assuming that we have a footprint for this device somewhere. And again, we don't need this to be visible right now, so add it as invisible. So this is the device name, this is the description, this is the footprint. And now, since I've added those, I can go back and shut off my invisible text view. Again, click save, make sure that things are getting saved, go back to this tutorial. Next thing we need to do is refdes. Okay, so now we need to add a refdes, which is basically reference designator. So again, I'm going to turn this on for the time being, and I'm going to add a refdes, and value is basically going to be u question mark, and that's basically because or maybe an x question mark. So in practical terms, it really doesn't matter if you're going just from schematic to PCB, it really doesn't matter what these letters are. However, if you're going to SPICE simulation, then it does matter, because based on the reference designator, SPICE is going to interpret certain things. If your component is called R1, R2, R3, basically any reference designator starting with an R, then SPICE by default assumes that it's a resistor. If it starts with a C, it default assumes that it's a capacitor, and so on and so forth. If it sees an X, then it means that it's a subcircuit. So it expects a subcircuit definition or a netlist, a SPICE definition for this component, which is typically how we would use this if we wanted to simulate it. If you are simulating ICs, usually, or the common usage is to use U as the reference letter. So we can use U for now, or we can use X, either is okay for the moment. So there we go. So now we put U as the reference designator, and the next thing we need to do is num slots. We can just put num slots equal to 1. So again, add attribute, num slots equals 1, and we don't need this to be visible. This is not a slotted component anyway. So where did, there we go. So I don't want this to be confusing, so I'm going to add there we are. So now all the text is lined up neatly. This may or may not exist inside the symbol, that's okay. For now I can put it up in this corner, and now I can go and shut off my invisible text again, save the file, make the num slots, footprint, description, graphical, and device, all of these need to be invisible. That's fine. We've already run that. Only refdes should be visible and it's at the top of our component. That's fine. So now the next thing to do is to add a label to the symbol, and we are going to put some text. So now let's add some text. So after you click apply, you need to actually drag the text to the right place, right location that you want. So this location is okay, and then I'm done. So there we go. And then if you want to zoom, all you have to do is VE, zoom extents. It basically auto zooms your display. And then I'm going to shut off invisible text, and there we are. So our symbol is pretty much all ready. Okay, so the last thing we need to do is do this symbol translate, but symbol translate is no longer available in the latest gEDA. So what we are going to do is we are going to go to I believe the option is called set origin, place origin. There we go. So we're going to place origin, and let's place the origin here. So there we are. So now that's our origin placed, and all we have to do is now we need to save as, and then we'll put it in the symbols directory. So before we do that, let's just do a save, and then that just saved it as schematic. Now save as. Now I'm going to save it as a symbol .sym lv25p .sym, and the convention is symbol name hyphen a number. So lv25p hyphen 1, and in general these are multiple symbols for different uses. So lv25p hyphen 1, that's fine. Last thing is we've basically checked all of these things, so these should all be good. Slotting doesn't apply to us, so this doesn't we don't need to go through this. And last thing is to run gsymcheck. So now we're going to save the symbol, so save and then close. Now to check this symbol, first of all let's do ls. So there we go. So now we have gschem running somewhere. No, we don't. So now we have this new symbol that we created. We have this was the schematic file that we used to edit and design our symbol, and now we need to run a check on this. So the way to do that is gSymCheck lv25p hyphen 1.sim. There we go. Okay, so the first error found is that okay, so one error found, -v to view details. So -v gets added here. Let's see what the error is. Okay, so missing slot def. Let's see why slot def was not found. So let's go back here. Okay, right, so num slots equals, we should have put it as 0 if the symbol doesn't need slotting. So we had put it as num slots equals 1. So one way, of course, is to go back to gschem and then lv25p-1.sim. we open this up. Now since my slot def was invisible text, I can go here and set it as num slots equals 0, right? And then I could save this again, basically doing the same thing that we did earlier. However, one interesting thing that, let me just close this without saving. An interesting thing to note is that because these files are all essentially text files, what I could do is to open this up using a text editor like maybe gedit, like so. And what it looks like in this text file is basically like this. So what version of gEDA and so on was it created in, some graphical information, and then what pins are there, what graphics are there, and so on and so forth. So all I have to do is look for this num slots attribute and I change it to 0, and I can just save this text file and we are done. So essentially, if I now open that file with gschem and show invisible text, you can see that num slots has now changed to 0. So now we quit, run gsymcheck again. There we go, no errors found. So now everything is clean, the symbol works, and we are done. So now let's try to extend this. We can have, like it was mentioned in the document, we can have multiple symbols per part. So let's try and make a new symbol for this, which captures a little bit more detail. Essentially, I want to replicate what is captured here in this diagram, and I want to put it in my. So now what I want to do is try to capture what's going on here in this symbol. So add basically just a little bit more graphics, make it look a little bit better. So first of all, view invisible text. First thing I want to do is move these text pieces a little bit further up. I can move this out of the way, and that's because I'm just going to add a little bit more graphics in here. So what do we need to add? We need to add basically this part. So let me do that. So I'm going to add an arc. What I want the arc radius to be is basically 50, and I want the degrees of sweep to be 180. There we go. So now I have this. Now I just need to rotate. So ER should rotate it. Okay, and since we are drawing graphics, we need a little bit more resolution, so I'm going to change my snap grid to 50. So now I need to draw the primary side. So I'm going to draw this, and for now let me disable this invisible text. So view, hide invisible text. Remove the show invisible text, and then this time I'm going to save as symbols, and this time I'm going to save it as lv25p-2. There we go, save. So now we've got that saved. Now save and quit. So essentially we followed this tutorial all the way. Okay, so now there's one thing we can look at is the sim version. So let's take a look at this sim version. We've done pretty much everything else. So sim version, there we go. So sim version can be used to version the contents of a symbol, right? So if you use a symbol with the wrong version of the schematic, or the schematic with the wrong version of symbol, you can run into problems. So now what we can do is right, so now let's add a couple of things. So first of all, let's add sim version. So sim version, adding that shouldn't be too difficult. So gsym lv25p hyphen 2.sim. okay, so we need to add the attribute sim version. To do that, let's just enable hidden text, add sim version, and let's call it 1.0, not visible, show name and value. So there we go. Save. But before that, of course, I should hide this invisible text and then file save. So the other thing I need to do is, of course, do the same thing for the other file. So one thing that we didn't talk about was the attribute value. So for this case, for a sensor, of course, there's no meaning to the attribute value, but if it's a resistor or capacitor, you can add a value attribute to say what is the parameter value that maybe Spice or some other tool is going to be able to use. Another thing is refdes naming convention. This is a very, very loose sort of convention, but generally it's required when you want to convert your schematics into Spice netlist and simulate with Spice, because Spice has a very specific way in which it interprets things. So for instance, I think E and F in certain kinds of Spice are, I think, control voltage sources or something like that. So you should be careful about how you assign your refdes letters, and depending on how they are going to be used. For instance, X as a crystal is very common for if you're just talking about circuits, but if you're talking about Spice, then X refers to sub-circuits or hierarchical designs. So you have to be careful there. The last thing we need to do, of course, is to make sure that our gsym is able to access those symbols. So let's go and see if we can do that. So home gaf symbols, oh sorry, it's still in projects, this one, and then let me copy these two symbols. Let me copy these two symbols into my symbols directory. So paste, there we go. And now let's start up gsym. So if I start gsym, I get a blank schematic, go to library, symbols, and I now have my LV25P and the second one. So the way I would use it is basically click here and then just drag the symbol out. Click here, drag the symbol out. So there we go. So that's the end of this session. Close without saving.